Okay, so hello everyone. Today I'm going to present you about the two-sample test of hypothesis. In this case is Mochi. So there are two types of tests, which is one-tail test and two-tail test. The one-tail test is contain left tail and also the right tail. We can see the difference. If the one-tail test it's only one rejection region, while the two-tail test it has two rejection region in the left and right side. Okay, we're gonna continue to the independent sample. The sample selected from one population that is not related to the sample selected from the second population. We would select a random sample from each population and compute the mean of the two samples. If there is a difference between them, then we expect to find a difference between the two sample means. If we find the mean of this distribution is 0, it means that there is no difference in the two populations. But if the mean of the distribution of difference is equal to some value other than 0, which is either larger or smaller, but if the mean of the distribution of difference is have other value than 0, we're gonna conclude that the two populations do not have the same mean. Lastly, we need to know something about the variability of the distribution of the difference. Then we have the two formula, that is z equal to x1 minus x2, and then divided with the square root of standard deviation 1 divided with n1, which is the first sample, plus standard deviation of 2 divided with the second sample. And then this is the second formula, which is the standard deviation 2 divided with x1 minus x2 equal to standard deviation of 2 divided with n1 plus standard deviation of 2 divided with n2. And then this is the example. Our store went to reduce the time of freezing the mochi using new machine. After using this for a day, our manager would like to know if the mean freezing time using the old machine is longer than using this new machine. The time is measured from when the mochi are put in the machine until it should be distributed to the buyers. Suppose that the significant level is 0.05. Make the decision and see if the freezing using old machine is longer. And in this table, we have the machine type and each of the sample means, standard deviation, and sample size. I calculated it with the statistic calculator. We can find it in the Google. And then we must also see the T-table statistic. Suppose that the significant level is 0.05, then we should see in the two tails part and find the 0.05. And in the below, we should see the z, then it should equal to 1.960, or the confidence level is 95%. So here's the answer. Firstly, we need to state the null and alternate hypothesis, which is the null hypothesis equal to mu s less than equal to mu f. And then for the alternate hypothesis, it is the h1 equal to mu s bigger than mu f. And then the level of significance is 0.5, then the critical value become 1.645. We're gonna make the decision by calculate test statistic, and then we use this formula based on the data from this table, and the z we get is 1.708. And then we decided to reject the null hypothesis because the t value is larger than the critical value. And then we're gonna next to sample test about proportion. We are often interested also in whether two sample proportion come from population that are equal. To conduct the test, we assume each sample is large enough that the normal distribution will serve as a good approximation of the binomial distribution. The test statistic follows the standard normal distribution. We also must compute the pooled proportion that possessing the trait in the combined samples. It is called the pooled estimate of the population proportion, and it is computed by using the formula, which is PC equal to x1 plus x2 divided with n1 plus n2. And for compute the value of z, the formula is P1 minus P2 divided with square root of PC times with 1 minus PC divided with N1 and plus PC times with 1 minus PC once again divided with N2. And for the example, our factory developed a new 2 variants of mochi. Our manager wants to know whether there is a difference in proportion of men and women who would purchase our new variant if it released to the market. There are 2 independent populations, a population consisting of the women and a population consisting of the men. Each sample will be asked to our mochi and indicate whether they are like the mochi taste well enough and to purchase it. We must state the hypothesis and make a decision. First, we need to state the null, and for the reminder, it is the 2-cell test. For the null hypothesis, it is equal to P1 equal to P2, and then for the alternate hypothesis, P1 not equal to P2. And then the level of significance is 0.10. And then we're gonna determine the test statistic using Z distribution. And then because the level of significance is 0.10, then the critical value we must using the table is equal to minus 1.64 and positive 1.64. And then we're gonna use the both of the formula, and P1 equal to 35 divided with 100, and we got the 0.35. And the P2, 90 divided with 200, and equal to 0.45. And for the pooled proportion, we sum the x1 and x2 and divided with n1 plus n2. Then the value of PC is 0.56. After we got the pooled proportion value, we use the Z as a test statistic, and then the Z value is minus 1.66. Next, we're gonna comparing population means with unknown population standard deviation or equal. In many cases, we do not know the population standard deviation. We can overcome this problem as we did in the one sample case in the previous chapter by substituting the sample standard deviations for the population standard deviation. We need to combine or pool the sample standard deviation and then use t-distribution for test statistic. These are the 2 formula that we are assumed that the standard deviation is equal, although it is unknown standard deviation. And then we're gonna next to unequal unknown population standard deviation. We didn't know the standard deviation, but in the previous slide, we assume it is equal. But we know that it is not always equal. Then it means that we must use the degrees of freedom formula that be adjusted downward by a rather complex approximation formula. The effect is to reduce the number of degrees of freedom in the test, which will require a larger value of the test statistic to reject the null hypothesis. And for the first formula, that is the t-test statistic, is mean of x1 minus mean of x2 divided with square root of standard deviation 1 square 2 divided with n1 plus standard deviation 2 square 2 divided with n2. And for the degrees of freedom, we can see here, it is quite complex, but it will be easier to use it. And for the example, suppose that our chief are evaluating the melting of 7 mochi from 7 different brands and then compare it to our 5 handmade mochi variants. We keep all this mochi in the same box and room and count at what minutes that they started to melt. Use the 0.10 significance level and test if there is a difference in the mean amount of mochi melted by the two types of mochi. A random sample of 7 mochi is 10, 95, 9, 15, 15, 12, 20, 17, and 8. And from our store, it is 10, 20, 25, 10, and 20. There is considerably more variation in the amount melted of mochi from the 7 different brands than from our stores. Suppose that the significance level is 0.10, and we should make the decision. Firstly, we must state the null and alternate hypothesis. Here's the null and alternate hypothesis. And then we must find the degrees of freedom by the information from the table. And then we're gonna see the process of the formula until it has the value of 6.169. And because of the degrees of freedom is 6, and then then it means we have the critical value is 1.943. And then the value of statistic using t-test is t equal to x1 minus x2. x2, it is the mean, and divided with square root of s1 double divided with n1 plus standard deviation 2 divided with n2. And then the value become minus 0.93. It means that we decide to accept the null hypothesis because the t-value is greater than the critical value. And for the last, it is two-sample test of hypothesis, which is the dependent sample. There are situations, however, in which the sample are not independent. To put it in another way, the samples are dependent or related. Dependent samples are paired measurements for one set of items. That means the measure value are connected. Independent samples, subjects in one group do provide information about subjects in other group. By using dependent samples, we are able to reduce the variation in sampling distribution. Here is the third formula, and we're gonna next to the example for make it easier us to understand these three formula. Example, our store wishes to evaluate the effect of offering 10% discount in a week to our buyers. Then our manager collect the total sales data in a week or 7 days before offering discount and 7 days after offering the discount to the consumer. Then they will compare each result to see if there is difference in the total sales mean and state the hypothesis and make decision. First, the null and alternate hypothesis is equal and not equal to 0. We're gonna find the degrees of freedom by total samples minus 1. It means that in a week there is 7 sample minus 1. It means that the degrees of freedom is 6 and the significance level is 0.05. Then it means in the critical value of 2 2.447. And we're gonna firstly find the mean of difference and standard deviation of difference by using these two formula. And then here's the data. The difference between the before and after in Monday, it is 15. We just see the difference. We can minus or calculate it. And then the D minus the mean become 1.43. And then in the last table, we're gonna square to it until it has equal to 2.044 and so on until Sunday. So the mean of G and standard deviation of difference become 13.57, and then the standard deviation is 22.28 square root and equal to 4.72. After we get the standard deviation and difference and the mean difference, we're gonna calculate the value of test statistic. And the value of it is equal to 7.593. It means that our decision is to reject the null hypothesis because our t-value is greater than our critical value. That means it is inside the rejection region. I think that is all from me. Thank you for your attention.